So whenever we talk about numbers, the first thing which comes to us is natural numbers. So can anyone define what is a natural number? Like what are natural numbers? So the basic definition here is the numbers with which we count the object of nature, like how many trees are there, how many rivers are there, how many mountains are there. So standalone objects nature में available होते हैं. We count them with natural numbers and starts with 1. So 1, 2, 3, all these numbers ahead, we'll call it natural numbers. So, and then we realized that absence of something, that doesn't mean it's not there. We need to count the absence also. Like when we talk about a number of people staying in a home, or the amount of money that I have, it may sometimes it may be nil. So we need to add 0 to this natural numbers, and we'll start with 0, 1, 2, 3. With 0, natural numbers with 0 is your whole number. And then with these two, we can define even numbers. Even numbers are all those numbers who get divided by 2. So n by 2 actually leaves no remainder. So how do we identify even numbers? You will say that any numbers when it ends with 0, 2, 4, 6, 8, then it is a even number. Like 538 is a even number. But the point here is, like, when we represent even number in algebraic format, we represent it as 2n, where n could be natural numbers or whole number. And n is a whole number. Similarly, odd numbers are all those numbers divided by 2, right? N by 2 leaves the remainder. Of course, it will be 1 only. And how do we denote these numbers? We tell it like 2n plus minus 1. So all these numbers should be an odd number. What are composite numbers? Anyone? लोग बीच में कुछ reply करते रहा करो. तो ही ना, what is composite number? So it should start with prime number. Actually, we could have talked about prime number first and then composite number, but it's okay. So let's talk about prime number first. Prime numbers are all those numbers which do not get divided by any number other than the number itself and 1. Like, let's take 5 or 17 or 23. So the total factor of 5 is either 1 or 5. Factor of 17 is either 1 or 17. Factor of 23 is either 1 or 23. So prime numbers are all those numbers which do not get divided by any other number except 1 and itself. So factors are 1 and itself. So यहाँ पे मतलब sometimes people get confused, and when they start writing prime number, they start with 1. But 1 is not a prime number. So prime number starts with 2, and 3, 5, 7, 11, 13. All these numbers are prime number. And the only even prime number is 2. So there's a very basic question I'll tell you. Let's say I'm asking prime number into prime number. Will it be a even number or odd number? Sometimes when we realize what are the prime numbers, if we don't realize that 2 is also a prime number, you'll see all the numbers which are prime will be odd. And odd number multiplied by odd number will always give you an odd number. So the answer, sometimes people give the answer odd because they forget that 2 is an even prime number. So prime number into prime number can be a even number also if any one of these prime is 2. So this is a catch here. Sometimes you will get a question like this based on this fact that 2 is a even prime number. So now you can define composite number as all those numbers which are not prime. Numbers which are not prime. And you can also say like they have more than 2 factors. More than 2 factors, like 1 and 1, the number itself, we will tell it prime, not prime, not the number itself, and some other factors, either 1 more factor or 2 more factor or 3 more factor and number of factors more factor. So they have more than 2 factors. So this is a composite number. So when we talked about prime number and composite number, a frequently used term you will get is co-prime number, right? And when we talk about co-prime, so we are talking about set of 2 numbers or 3 numbers like 5, 8, 4, 10. I'm writing all the set of numbers where we will find which of these sets are co-prime. 7, 15, and 64. So similarly, we can write different sets here. So what do we see here? That 5 and 8. 5 has factor 1 and 5. 8 has factor 1, 2, 4, and 8. So there is no common factor. No common factor except 1. So 1 will be a by default common factor of all the set of numbers. So if we get any other factor other than 1, common factor other than 1, those numbers will not be a co-prime numbers, but this set or this type of pair will be called a co-prime number. Like 5 and 8 are co-prime to each other. But when we see this set of numbers, we can see that 2 is the factor of both of the numbers. So this set of number is not co-prime to each other. And again, if we see here that this is a prime number, here you get factor 3 into 5, here you get 2 to 5, 6. So no common factor is there other than 1. So that's why these 3 numbers are co-prime to each other. So when we talk about co-prime numbers, the prime name or prime numbers, the definition of prime number doesn't hold here. It's just like no other common factor than 1. So if 2 prime numbers are there, P1 and P2, will it be a set of co-prime number or not? They will not be a co-prime number. Can anyone tell me? P1 and P2 together, are they co-prime to each other? Hello? Anyone? Anyone tell me, Jagriti? A set of two prime number. I'm taking a set of two prime number. Can they be co-prime to each other, or they may not be co-prime to each other? Ved? Hello? 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 Anyone?
I think.
हाँ जागृति बताओ. आवाज नहीं आ रही तुम्हारी. You can write it on
each other because to be co-prime there has to be only one common factor.
Yes.
सर आवाज आ रही है मेरी?
हाँ आ रही है, बताओ.
हाँ जी, मैं कह रही थी कि दो प्राइम नंबर्स आई गेस co-prime होने चाहिए because
I guess नहीं, they will always be a co-prime. They will always be a co-prime because they don't have factors even to get it as a co-factor or common factor. So the only common factor they will have will be 1. So all the prime numbers together are co-prime to each other. Good. So now the next thing that we got is, I'll first talk about fractions, and then we'll talk about rational numbers. So, so when we count the objects which we use daily or which we can divide into parts, so they may not be in integer or natural number, or they may not be the whole number. Like you can say that I ate 1.5 pigeon, or this can also be said as you ate 3/2 pizzas. So here the number is not whole. So we use fractional component to represent the part. So 1 is the complete number here, and 1/2 is the fractional component. So you know that all these numbers like 2/3, 5/2/3, all these numbers are fractional in nature. So this is less than 1, or this is 5 and 2/3. So this number is basically 5 as whole, and for the next circle you will get 2/3 of this next circle. So this representation is 5/2/3. So we call it mixed fraction. So with this definition, we defined rational number. All those numbers which are either integer or whole number or represented in parts are rational numbers, like 18/7. We can write it like 24/7, or anything of such denotions are rational number, and we can just say even just like 18 is also a rational number because it has been denoted as 18/1. So we don't write 18/1 always. So any number which can finally be denoted as P/Q, where Q is equal to not 0, will be called a rational number. Okay? And all other numbers which cannot be represented as P/Q will be called irrational number. So now here you will find some interesting fact that when we convert the fractional number or fractional number into decimal number, so what do we see? That when we divide 19/2, so what do we get here? 9.5. Or 23/5. What do we get here? 4.6. So all these numbers which are being divided by 2 or 5 or mixing 2 or 5 together, either they will leave no remainder or they will leave 0 after decimal. But if they are leaving something after decimal, the decimal value will terminate. Like there is no other value after 0.5. Similarly, there is no value after 0.6. So these decimals which gets terminated, we call it decimal value is terminating. But when the same or the same mean, when the numbers are being divided with the other in numbers, other whole numbers, which is not 0, like if we divide 19 by 3, so what do we get here? 6.33333, and it goes on. So we write it as that 6.3, and we put a bar here, which represents that this number, anything which is under this bar, is being continued till infinity. So if you divide any number, like if you divide like 15 by 7, you will be getting something like 2.1456 to 8, something like this. I don't remember exactly, not 8, something like this. And you will have bar on this 6 digits. That means this decimal will keep on repeating this 6 digit till infinity. So all numbers which are, when we divide any number by 2 or 5 or any number which has been made with 2 and 5, like if we divide a number by 25 or 100 or like 125, all these decimals will get terminated somewhere in like either 1 digit or 2 digit or 3 digit. But when we divide a number by 3, 7, even mixture of 2 and 3, like 6, so either it gets finished after decimal, or it can go till infinity, because it's being divided by 6. Like if we divide 33 by 6, it's basically 11 by 2. So in this case, it will get terminated. But if we divide 44 by 6, so it will be 22 by 3, and since 3 is there, it will get continued till infinity with any recurring digits. So what do we see here? Like any divisor which is being made by 2, 5, and the combination of 2, 5, the decimal value will get terminated. And if it is 3, 7, and other number, other value which has some other primes, it will not terminate, it will not get terminated, but it will recur. And the value which recurs, we put bar on that. Okay. So all these numbers are rational. All these numbers are rational. But other numbers where decimal values doesn't get terminated are irrational. But how do we find that? So irrational numbers actually exist in nature. Irrational number, we don't create it by dividing two numbers. We don't create it by P by Q. It exists in nature. So one of the most confusing or known irrational number is pi. So for many people, when you ask is pi is a real number, they will think that pi, the value of pi is 22 by 7, which is in P by Q only. Then pi must be a rational number, because we have defined that rational number are all those numbers which can be represented as P by Q. But actually Pi is not exactly 22/7. It is a approximated value. It is a approximated value for pi. Approximated value for pi. The pi has a value which is 3.140 something, and it will go till infinity. It never gets terminated. So this is the value of pi. Okay. So that's why pi is a irrational number. So you can they can in test exam they can ask a question that out of all these numbers, which are irrational number. The other favorite irrational number which we get is e, exponential, which is like 2.71 something. I mean, okay. So other irrational number is e, exponential, the value of exponential. It is also a natural number. It automatically comes while calculating a compounded uh, equation. And some more irrational numbers are like root 2, root 3, any root which is not perfect square, any number which is not root of any number which is not perfect square. Root 5, all these values are irrational numbers. The value of root 2 is 1.414. This is what we write, and it is approximated value of root 2. Otherwise, it goes till infinity. Similarly, the value of root 3 is 1.732, but it goes ahead, and same stands for 5. Okay, so this is how we identify uh, natural numbers, sorry, irrational numbers. And sometimes, since I've introduced the root here, mixed numbers are also there, which is like combination of rational and irrational number, like 2 plus 3 root 2 is a mixed number. We call it a mixed number. Okay, is it okay? Is everyone getting what? Am I clear till now?
Yeah.
So we were talking about the decimal representation of rational numbers, where in sometimes they got terminated, or for some in sometimes they were recurring. So finding a decimal value is easy. You can just divide the number by the divisor. But finding the fractional value from a decimal value, sometimes uh, students get confused in that. So like if we have a number 2.4, and we have a recurring like bar there on 4. So in this case, what I'll do, I'll write 2 differently, and the number for which the bar is there divided by n. So this is how we calculate the fractional value of 2.4. If it is 2.04, we have bar for both, then we will write 2 plus 0.4 divided by 99. Or, but sometimes you can also get a number as sometimes you can also get a number as, I'll tell you. Sometimes you can also get a number as 2.04, but the bar is on 4. Like only 4 is getting recorded. So in this case, the number would be 2 plus 4 by 90. So the 9 will write 9 or 99 or 999 will write only for the digits for which bar is there. Any digit which is ahead of the bar will write just a 0 for that. But what if the number is 2.34 and the bar is for 4 only? So you can break the number as 2 plus 3, 0.3 plus 0.04 bar. We will divide it by dividing, break the number into these three parts, and then 2 plus 3 by 10, which you know, and then here you also know that 4 will be as the numerator. As denominator, you will write 90. So, are you getting my point? Is everyone getting how I did it?
Yes,
So
sir.
this is all the options that you can have. Let's say if I'm asking you, just tell me the break. How will you break this number? So if I'll ask you like 2.1738 and the bar is on 72, is how will you convert this into fractional value? Anyone? बोलो, इलास्टिका कैसे करोगे इसको? जागृति?
सर पहले तो डेसिमल पॉइंट्स पे ऐसे ब्रेक किया था.
नहीं, ये पॉसिबल नहीं है. So once you got the recur, you will not get any digit after that. Okay? So it will never be like 2.173 and the recurring decimal is just 73 and then you have 8. That means you are terminating it after some time. But it's not any decimal will not be in this structure. Okay? So now let's write the another number. 2.1738 and we have bar on 38. So how will write that? Tell me. हम लोग उसको break करेंगे. We'll break it 2 plus 0.17 plus 0.0038. We have a bar on it. Then 2 plus it will be 17 by 100. We all know how to break or convert this into decimal. And then for this, we will write 38 as a numerator, 99 for all the recurring digits, and 00 for the 2 zeros, which was ahead the recurring number or recurring digit. And then we will solve this all to get the final fractional representation of the same number. Did everyone get that?
Yes, sir.
Very good. So, surds and indices. Can you define what is surds and what is indices? Huh? Surds and indices. What is surds? Tell me, anyone.
Square root values.
Not only square roots, all the actually we can also call all the values as roots. There's a third root and fourth root and fifth root, we say. But it's like, and what is indices? Hello? Integer powers are indices. बताओ जल्दी. Okay, चलो मैं बताता हूँ. Let me explain. So like if you multiply a number multiple times, like n into n, we write it n square, n into n, we write it n cube. So these powers are basically indices, and we get it by multiplying by multiple same number multiple times. And when we get a value if we multiply 2 into 2, it will be 4. But if when we represent root 4, that means which number will give you x into x as 4. So basically we need to find this x. So the root is third. So sometimes when you say x into x into x is x cube, and when you want to go back, so we will write third root x cube. So it will give you x. So and sometimes the power is mixture of both, like when there is a number called like if 8 has a power of 3 by 2 by 3, 2 by 3. So it has both. We have 8 into 8 for this square, and I need to take 1/3 root of the third root of 8 into 8. So when you have something like this, you can either start with squaring it, or you can also get the third root of 8 first. So if someone is asking what will be the value of 2 by 3, so how will calculate? You will first write, either you will square it, or you will write the third root of 8, which is 2. Then you will square it to get 4. Or you can also do it otherwise. First you can square the number, which is like 64, and then you can get the third root. 1 by 3 and 1/3 root of 64 is same thing. Then you can get 4, because 4 into 4 into 4 you can get 64. So mixed powers are also there. So the point and the lesson here and the learning objective here is that irrespective of powers, like even the surds can also be used or can also be written as power here. I already gave you the example, like root 2, we can write it as 2 to the power 1 by 2, or 7th root of x, we can write x to the power 1 by 7, 7th root of x. So once it has been represented in power, now we can calculate everything with respect to the power only. So if we're writing a to the power m divided by a to the power n, what will the value of this? So everybody knows that both power will the m will be subtracted from m. So m minus n. Can anyone prove this? How it happens or why it happens? You don't have to prove it. Actually, it's kind of axiom. It is self-proof. Like if we are writing 8 to the power 5 and divided by 8 to the power 3. So basically what we are doing here, we are multiplying 8 5 times, and then in the denominator we are multiplying 8 3 times. So of course these 3 times and 3 times will get cancelled, and 5 minus 3 times will be left over. So that's why when divided, power gets subtracted, 5 minus 3. And opposite to this, when multiplied, like 8 into 5, 8 to the power 5 into 8 to the power 3, the value of this calculation would be addition of these powers, like 8 to the power 8. So how it happened? We can just multiply 5 times 8, and you also have to multiply 3 times 8. Basically, ultimately, you are multiplying 8 times 8, which is 8 to the power 8. So these two things you have to remember here. If something is written as this, you can m plus n. So this is the calculation based on power. Some examples will be doing ahead where this particular formula or thing is being used. First, let's finish the definition things first. What this number system do we use in our regular calculations? We use decimal systems. Everyone knows that. Decimal system. And decimal system of counting says that you have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You have 10 digits. And how do we count? We say anything as we count it like 1, 2, 3, 4, 5, 6, 7, 8, 9, and we don't have any digit for 10. What we say 1 time 10 completed. And similarly, when you write 1, 1, 2, 1, 2, 11, 12, and finally you write 2 time 10 completed. And lastly, you will write 9 time 10 completed. And then you will have 91, 92, and 99. And then finally you will write 10 times 10 completed. Like this one will be replaced with 100. So this is how we count, and any number which is written in decimal system will have a series of digits written together. And how do we identify the value of that number? We counted how many tens has been counted or being passed. Like if we have number 5 to 8, so we know that 5 times 100 is being concluded, written, 2 times 10 is being written, and 8 standalone. So we know that we have this structure of numbers. We can also write it like 5 into 10 to the power 2. Like every digit, every place has its own value and power. So this 5 will be written as 5 into 10 to the power 2. This 2 will be written as 2 into 10 to the power 1. And this 8 will be written as 8 into 10 to the power 0. So every place of a number, we have a different value, right? If you are writing a number 5, 1, 3, 5, 2. So we have 2, 5 here. Both has the value, face value of 5. But the place value they have, this 5 will have what place value? 5 into 10 to the power 4. And this 5 will have place value 5 into 10 to the power 1. So in decimal system, the place determines the power or contribution of that digit in that number. Okay, so this we have already covered here. So operation and roots and power, we have already explained this. What are the roots and powers? Operations and roots and powers we have explained on the basic level. Mixed rational number. We have talked about that there are numbers which are called mixed numbers. 5 plus 2 root 3. And so the calculation we'll be doing in next class. Okay. So other things of the same definitions part, we'll be doing it tomorrow, and we will also cover SCF and LCM, not tomorrow, in the next class. Okay.